What do we all love more than life? Hate more than death, and mortal strife. That which contented people desire, the poor have, the rich require. The miser spends, the spendthrift saves, and all must carry to our graves. Nothing. But where the hell does nothing come from? Murray Fredericks is a landscape photographer, except he doesn't photograph landscapes, or at least he tries not to. He treks the world over for, in his words, minimal landscape, and to try and photograph almost nothing on Earth. Maybe his images conjure up something like what you imagine when you try and picture nothing, a big black or white empty space. It's this nothing that tends to rear its head when we think of things like what happened before the Big Bang. Nothing. But I'd argue it's even less than this black screen can represent. Like, what's north of the North Pole? The answer, of course, is nothing. But this doesn't mean that there's some sort of imaginary realm of nothingness floating nearby the North Pole. And this is kind of how we can think about the Big Bang too. How about we just take nothing at face value? Literally, no thing. Any person will tell you that if Jill has 10 apples and Jack steals those apples, then Jack is a dirty thief. Oh, and Jill's basket contains nothing. It's possible to formalise this realistic depiction of Apple's tax policy using set theory from mathematics. Sets, by the way, can be thought of roughly as collections of objects. So, what's the simplest set? Well, it's the one with no objects in it at all. It's basically the mathematician's version of nothing. Oh, sorry, 0. You see, 0 is a number with a bunch of arithmetic properties, and that makes it much more than nothing. In fact, we can put 0 into the empty set, and then it wouldn't be empty anymore. But the empty set has an interesting use. We can place empty sets inside of empty sets in sequence forever in order to define all the natural numbers from scratch. In an alchemical sort of way, we can make something from nothing. But let's go back to Jill. You've taken all the apples out of your basket, but do you really have nothing left? No, because of all this pesky air. And that's certainly not nothing. Just ask those sharks. What do you mean that's just a movie? Thought it was real. Air gets everywhere with its billions and billions of particles hurtling about. Is it even possible to get rid of it without some more rushing in to fill its place? Everyone said no for a long, long time. Well, actually they said, this is Latin for nature abhors a vacuum. You can see why all this discouraged people from performing experiments, and again we have Aristotle to thank for this postponement of progress. It took a plumbing problem in 17th century Italy to sort this mess out, because who you gonna call? Galileo. It turned out that pumps in the river stopped working when the water was lifted up 10 meters, although there was nothing wrong with the equipment. Word got out about this conundrum, and soon Italy's scientists were devising experiments, and the solution landed at the feet of Evangelista Torricelli. He got a bucket of mercury and then a long glass tube which he filled with mercury too, and then turned it upside down and plonked it in the bucket. What happened was this: the column of mercury fell a little, but then stopped. What was in that 24-centimetre gap? Everyone agreed it couldn't be air, because they knew air could travel neither through glass nor mercury. That meant, horror of vacuize, it must be nothing. And they were looking right at it, or through it, or... It's confusing talking about nothing. Okay, so maybe we have made a vacuum at the top of the tube of mercury. But how? Well, it may seem at first that horror vacui kicks in halfway through, and the gap starts to resist being made larger, sucking the mercury up the tube until it hits equilibrium. But it's actually much simpler than that. The weight of the mercury in the tube pushes it down until it's perfectly balanced with the weight of the atmospheric air pressing down on the surface of the mercury in the bucket. The experiment electrified scientists across Europe. French polymath Blaise Pascal realised that if he took one of these from sea level, 750 metres up a mountain, then the mercury would drop in the tube corresponding to the decrease in air pressure in the atmosphere. He'd invented the barometer. Because we all use those every day. No, we've got one over here, look. Then Pascal did something different. He swapped out the mercury for water or wine, and since they're much less dense than mercury, he needed much, much taller tubes. Lo and behold, they both stopped dropping when they hit the 10-metre mark, explaining the plumbing problem. Funnily, the history books don't record what happened to all that wine afterwards. Otto von Guericke, the Burgermeister of Magdeburg performed a pretty over-the-top experiment to go with his over-the-top name. He constructed the world's first vacuum pump and used it, naturally, to evacuate and seal 2 giant metal hemispheres. Then he instructed 2 teams of 8 horses to pull it apart in a tug of war in front of a crowd. They couldn't separate it with all their might, but after letting the air flow back in, the Burgermeister himself easily parted them with his bare hands. It was like magic to the onlookers. To see what other properties this nothing had, the 2 bobbies, as no one ever called them, tweaked Guericke's pump and shoved a bunch of things inside, like a light, proving that light can travel through a vacuum, a bell, proving that sound can't, and a bird, proving that they're sadists who love a bit of Enlightenment era crowd pleasing. So we've got the apples out of the basket, we've shut the lid and pumped all the air out, then we put a bird in and taken the bird back out again, and hey presto, nothing. But it's not nothing yet, it's just less. Those pumps weren't powerful enough to remove all the air, and that pesky mercury in the barometer actually gave off vaporized atoms that filled the void at the top of the tube. So in all those vacuums there were still particles floating about, like around 100,000 times less particles, but still a lot more than 0. Now there were only 1,000,000 billion particles per centimetre cubed. Oh wait, that's loads. But the production of light bulbs and cathode ray tubes spurred development of vacuum technology, as did the manufacture of semiconductors in the 20th century. And today, researchers have gotten all the way down to 1 molecule per centimetre cubed, the lowest pressure ever. Well, man-made pressure. I guess it's kind of obvious that space is empty, it's a whole load of nothing. But not uniformly. If we look at the space between planets, we still find 10 or so atoms per cubic centimetre. Between stars we find just 1, like our most powerful vacuum on Earth. But then between galaxies, we find only a few hydrogens for every cubic metre. I'd say this is pretty nothingy. And that's just the nothing of outer space. What about inner space? What's inside an atom? After all, don't sciencey people love saying that these are mostly empty space? I mean, here's the tiny nucleus, and here's the tiny electron whizzing around. If we ignored all this empty space, we could condense all the real matter of 7 billion humans to the size of a sugar cube. Except we can't, because it's not empty, and it's not empty because that is not an electron. Or at least, we can't be sure it is, because it can be here, or there, or anywhere, and in a way it is. It's a dispersed probability occupying the space that was previously supposed to be empty. Actually, why did I have to bring up quantum? There's some bad news for the emptiest of intergalactic space. You might want to get your horror vacui placards back out. This is the part of the video where I tell you that the supposed empty vacuum of space is actually teeming with a bubbling sea of virtual particles popping into and out of existence on tiny scales. Ooh, mysterious, weird, profound. But what the hell does this actually mean? First, we need to think about the universe differently. There are no particles, there are no waves, there are just fields. And it's these quantum fields that give us things that we often usefully interpret as particles and or waves. But they also give us other things. And there are a bunch of these fields, 1 for each elementary type of particle, and they permeate all of space. So when we see an electron, for example, this can be thought of as a ripple in the electron field that travels in a particularly stable manner. We can also get unstable disturbances that don't hang around that long, but still carry energy. These are what are usually called virtual particles, but they're really nothing like a particle at all. While these unstable disturbances, or virtual particles, can be caused by the interactions of defined ripples in fields, almost like the wake of a boat, there are no defined ripples in empty space by definition to cause them. So how do they appear here? Imagine a pendulum simply swinging back and forth. It has some definite amount of energy that is exchanged between kinetic and potential. But what does a pendulum look like with no energy? This. Boring, right? It just sits at the bottom with 0 kinetic energy, 0 potential energy, waiting for someone to give it a shove. But if we shrink this pendulum down to a quantum scale, it doesn't quite work the same. Try to reduce its potential energy to 0, and its kinetic energy becomes indeterminate. Reduce its speed to 0, and its height becomes indeterminate. What we can do is reduce both the kinetic and potential energy at the same time, so that the product of them is at a minimum, but still not 0. This is Heisenberg's uncertainty principle. We get a good-ish idea of where the pendulum bob is and what it's doing, but not perfect. Now, a field can be thought of as a grid with these quantum oscillators at every point infinitesimally close together. Given that the minimum possible energy is greater than 0, this means that the quantum vacuum, empty space, has non-zero energy. And what can you do with energy? Create those unstable disturbances. Horror vacui indeed. And by the way, this isn't just happening in deep space, but everywhere. In your living room, inside your head, in any gaps between the stable ripples of your atoms. But now maybe you've twigged that the goalposts have been moved somewhat. Are we even talking about nothingness anymore? After all, quantum fields are not nothing. They permeate all of space and have an associated energy. What seemed the very logical idea of subtracting apples and air from our basket has hit a dead end of seething quantum soup. Nature indeed seems to abhor a vacuum, but at least allows us to understand when we're out of apples. So where the hell does nothing come from? The answer, it seems, is nowhere. Thanks for watching. That was Where the Hell Does Nothing Come From. If you want to check out another of my sciencey videos, we've got Chaos, we've got Parallel Worlds, we've got, what else? Gravity, thank you, green screen. So if you like the video, please subscribe and tell your friends. We'll see you next time. Cheers, bye.